Welcome to the Bob Bloom Show with your host, Bob Bloom, a production of South LaSalle. Welcome to episode 18 of the Bob Bloom Show, PHP Developer's Guide to PHP Servers and Serverless, Part 2, Working Towards Go. Today is Friday, March 1st, 2024. The Bob Bloom Show is my monthly commentary podcast devoted to PHP, published on the first of the month. My main focus is pairing PHP with serverless platforms. This is your podcast host, Bob Bloom. The links referenced in this episode are listed in my notes at bobbloomshow.com, episode 18. I know that my Apple podcast listing is not updating. Apple is having trouble updating from my RSS feed file. They say that my feed file URL is returning a 404 for this podcast and for my PHP serverless news podcast. The exact same URLs work fine for Spotify. A couple of episodes ago, I tried out an AI podcast editor. The way that worked was it first created a scary accurate transcription. Then it washed through this transcription to rid of pauses. And there were plenty of pauses to remove. Some pauses were troublesome for the AI, so I edited them manually, causing abrupt halts. Then I went over the transcription and made very, very minor edits to the wording. Then the AI regenerated my audio, which scares the heck out of me to hear my voice being artificially recreated. Previously, the way I went about it was spending a lot of time manually going over my audio's waveform. My speaking style leaves a lot to be desired. Long pauses in the middle of sentences, saying all over the place. It can be frustrating enough to want to abandon listening, and I know this because I listen to my own podcasts, and I experienced this myself. If this happens to me, well, imagine my listeners. There have been many, many late evenings where I edit out my pauses to ease my audience's frustration with my lack of rhythm. Well, listening to my voice recreated by AI makes me quite uneasy. Now I perceive my pauses and frustrating speaking styles an integral mark of personal authenticity, and in doing so, I stop worrying about it so much, and in a funny way, I have improved a little since I relaxed a bit about it. Now, I have since recorded a couple of podcast episodes in the old way. My speaking style is improving, and it's funny how that has worked out. This episode is my second in a series about my personal journey into PHP servers. Now, PHP has always had a server aspect to it. I have just been very successful in avoiding it for a very, very long time. Ironically, it was something called Serverless that got me to take my first earnest step into it. You would think that something called serverless would translate to no servers, but at least in my own personal experience, it has been quite the opposite. Maybe it has been like this because PHP does not work with AWS Lambda out of the box. AWS has built a facility where you can use Lambda with non-native languages. Using this facility, the Runtime API, got me into the PHP source repository in github.com. And from there, I've been more and more into serverless and servers. An important impetus for me getting into PHP servers is my local PHP groups. Now, the topic came up in a very oblique way, but I pursued it as a new, fresh topic to present, which it was. Jumping ahead, I've come across two tangible points of contact between PHP servers and PHP serverless. The first is the term worker. It seems like all the servers use this term. Lambda also uses this term. The second is Roadrunner's documentation explicitly talking about using Roadrunner with Lambda. These tangible points of contact heightened my interest in PHP application servers exponentially. I decided to share my journey into PHP servers in real time by way of this, my commentary podcast. I would do a series of episodes. Being a commentary show, I could recount my journey in the first person and add a lot of commentary as I went along. A wonderful dynamic is shaping up. Going through my journey in real time in my monthly episodes is spurring me to be a bit more thorough than I think I would otherwise be. I want to relate substantial things on my podcast, not just sound like I'm doing some kind of play-by-play. It is not so much like research as much as it feels like I'm going deep down into rabbit holes. It is making me quite late with publishing my episodes, even though I'm backdating them. But right now, doing these episodes is really helping me with that extra oomph to get the baseline knowledge that I need to grasp PHP application servers. I'm starting from the ground floor, so to speak, so this dynamic is proving quite fruitful. Last month was my first episode in the series, and as important as it was in getting me to dig into the mod PHP and php-fpm source code and the PHP source. Can I say that again? Last month was my first episode in this series, and as important as it was in getting me to dig into the mod PHP and php-fpm source code and the PHP source repository at GitHub, I thought it would actually strike my listeners as rather trite. This month, I journey into the Go language, and what is profound for me might strike my listeners as long-winded and boring. On the other hand, my intuition says that this journey into Go, this episode, is pivotal in my journey to understand PHP application servers. What really helped me understand things was getting into the origins of Go. I want to linger on this story in this episode, which may make this episode a little long-winded and boring, but in the hopes that some extra editing will help mitigate this result, I am going through my late night draft. PHP application server terminology to me is a wall. I have no idea what it means. Its lexicon is opaque. 3 things happen when I read documentation. 1, the terminology sounds kind of familiar, and so I think I kind of understand what they are talking about. 2, I feel that this is pretty common terminology, and so somehow I should understand it. And when I read PHP application server terminology, the 3rd thing that hits me is I need to absorb the plain truth that I don't understand anything I'm reading. I decided that the best thing for me would be to start my journey by going back in time and digging into mod PHP and php-fpm. Because I was not really familiar with these, maybe I should start there. And that's what I did last month. This month, my starting point is the word worker. This term worker pops up everywhere, and it is an important Lambda concept, unique, that this term is common to the app servers and to Lambda. So I thought, hey, let's start there. The Roadrunner PHP application server strikes me as some sort of, I don't know how to put classic or like what a PHP application server would look like. I don't know if that makes any sense. I could be completely wrong, but I have to start somewhere in this journey, and looking at Roadrunner first seemed a very natural starting point for me. Its documentation has a section devoted to workers, and when I read it, it seemed to make sense, and I thought the way they laid it out made it obvious what they were getting at. And of course, after reading it over and over again, came to the conclusion, I don't know what the heck they were talking about. I knew it when I closed my eyes and tried to explain what I was reading to my screen, and my screen put its hands over its ears. For no reason beyond just having something to do, I went to the home pages of the PHP servers that I had on my list, only 5 of them: Swool, OpenSwool, Roadrunner, Caddy, and FrankenPHP. Now, Swool and OpenSwool are written in C. The other 3 are written in Go. Not that that mattered to me at the time because it didn't, but what surprised me was something that I just didn't notice before. It was so darn important being written in Go that Roadrunner and FrankenPHP proclaim this fact in their H1 tag at the top of their homepage, and Caddy proclaims it on their docs homepage immediately after their H1 tag. So why is it so important to ensure that we know what languages use? I mean, what difference does it make? So I paused, looking at Roadrunner, thought I should take a look at Go, which proved to be a pivotal moment. This is my first foray into Go, and my goal is to find out why Go is so attractive for writing PHP application servers. My goal is not to program in Go, although I must say I'm thinking that perhaps it might be an interesting tool in the tool bag, which I guess would be a bit of heresy for a PHP podcast. Although I have not been interested in any language besides PHP for 2 decades. Go is the first one that has even remotely caught my interest. I was musing that maybe there would be times when it'd be advantageous to use Go directly to enjoy its concurrency. I tucked away that idea. Maybe PHP application servers have a facility where we can access Go's concurrency in our PHP development. That is somehow incorporate the Go routines, but I am getting way ahead of myself here. Way ahead. Maybe I will do a Go Hello World, but for now, I have not had that burning curiosity. But I'm very interested why Go is the language of choice for PHP application servers. Now, just as stated, according to the wiki, and again, all the links will be in my show notes on my website, Go is a statically typed, compiled, high-level programming language designed at Google by Robert Gresimier, excuse my pronunciation, Rob Pike, and Ken Thompson. It is syntactically similar to C, but also has memory safety, garbage collection, structural typing, and CSP style concurrency. It is often referred to as Golang because of its former domain name, golang.org, but its proper name is Go. Now, to me, there's a server, there's an operating system, there's a programming language. And for reasons that maybe I can't quite fathom, these 3 things, the twain never meet. There's an OS, there's a server, there's a programming language. They're in their own separate silos. And this is completely wrong. And researching for this very episode brought the connection to light. For me personally, this is a profound discovery. And what really helped me was reading the history of Go. The key thing about it for me is Ken Thompson. I'm surprised that his name does not ring a bell. He worked at Bell Labs, which definitely does ring a bell. And that is going back, way back to the go-go days of the 1960s. There was a period in the 1960s stock market called the go-go year. The pun is very much not intended. Technology stocks were hot and were a big part of the go-go years. In my opinion, it was this period that provided the basis for the personal computers because money went into technology in a way that it hadn't before. There was a lot of disruption, and it was just a good basis. Anyways, I'm going to paraphrase and edit from a small part of the Bell Labs article called The Development of the C Language. The late 1960s were a turbulent era for computer systems research at Bell Telephone Laboratories. Bell Labs was pulling out of the Multics project, which had started as a joint venture of MIT, General Electric, and Bell Labs. By 1969, Bell Labs and the researchers concluded that Multics would need too much time and money. An informal group, led primarily by Ken Thompson, had already begun investigating alternatives. I'm repeating the name Ken Thompson. Ken Thompson led an informal group at Bell Labs poking around at alternatives to the Multics project. Ken Thompson wanted to create a comfortable computing environment that incorporated innovative aspects of Multics, especially process as a locus of control, a tree-structured file system, a command interpreter as user-level program, simple representation of text files, generalized access to devices. Thompson was faced with a hardware environment cramped and Spartan even for the time. The DEC PDP-7, on which he started in 1968, was a machine with an 8K 18-bit words of memory and no software useful to him. Okay. I think it's kind of laughable reading about what was big in the 60s. But I think you'll see there's some sort of continuity here to the story. We need to start with what he was working on way back when. While wanting to use a higher level language, he wrote the original Unix system in PDP-7 assembler, which is a low level language. At the start, Thompson did not even program on the PDP-7 itself, but instead used a set of macros for the GEMAP assembler, which I never heard of, on a GE 635 machine. A post-processor generated a paper tape readable by the PDP-7. These tapes are carried from the GE machine to the PDP-7 for testing until a primitive Unix kernel, an editor, an assembler, a simple shell, command interpreter, and a few utilities such as the Unix RM, cat, and CP commands were completed. After this point, the operating system was self-supporting. Programs could be written and tested without resort to the paper tape, and development continued on the PDP-7 itself. Ken Thompson's PDP-7 assembler outdid even the DEC, the DEC. DEC is the company, and PDP-7 is the computer. The DEC PDP-7 in simplicity. It evaluated expressions and emitted the corresponding bits. There were no libraries, no loader, or link editor. The entire source of a program was presented to the assembler, and the output file with a fixed name that emerged was directly executable. This is what Ken Thompson did. The entire source of a program was presented to the assembler, and the output file with a fixed name that emerged was directly executable. Around 1969, Thompson decided that Unix, a play on the name Multics, needed a system programming language. Guess what that language ended up being? After a rapidly scuttled attempt at Fortran, he created instead a language of his own, which he called B. B can be thought of as C without types. More accurately, it is BCPL, squeezed into 8K bytes of memory and filtered through Thompson's brain. C came into being over the years 1969 to 1973 in parallel with the early development of the Unix operating system. The most creative period occurred during 1972. Another spate of changes peaked between 77 and 79 when portability of the Unix system was being demonstrated. Now, is Go just the current fashion for writing PHP application servers? Is Go looking more like a long-term thing? Because one thing I'm looking for the trends. I kind of want to avoid the fashion. But my sense that Go is a long-term thing. Really long-term thing. The people involved with Go were there with Unix and C spanning 4 decades. There was a meld of the academic, corporate, and practical. Go was developed at Google and now is governed by an open source thing. I don't want to get into this. Anyways, there's a open source governance of Go. Now, Kubernetes was developed at Google using Go, and Docker is written in Go. So what is the problem that Go was solving? From Golang.design/history, the Go language was created by Rob Pike, a U of T grad, Rob Gressimer, and Ken Thompson. Rob was bothered by the slow C++ compiling times. So he talked to Robert, and luckily Ken was in the next office. From an article at Medium, in 2007, Robert, Bob, and Ken worked at Google. They were trying to tackle some of the engineering challenges they faced. Google, due to its scale of operations, faced engineering challenges unlike many other organizations. Selection criteria for the trio to identify which programming language to use centered around 3 main considerations: efficient compilation, efficient execution, and ease of programming. Though they evaluated many of the existing languages, they couldn't find any language which offered all 3 of the primary considerations. That realization led them to think about creating a new programming language. Thus, the seeds to develop Go were planted. The design began in September 2007 as a 20% project at Google. As things progressed, many others joined as well. In January 2008, work on initial compiler started. The language was open sourced. Later in November 2009, the first stable version was released in March 2012. From the talk section at the Go website that Rob Park gave in 2012, the Go programming language was conceived in late 2007 as an answer to some of the problems we were seeing developing software infrastructure at Google. The computing landscape today is almost unrelated to the environment in which the language is being used. Mostly C++, Java, and Python had been created. The problems introduced by multi-core processors, network systems, massive computation clusters, and the web programming model were being worked around rather than addressed head-on. Moreover, the scale has changed. Today's server programs comprise tens of millions of lines of code, are worked on by hundreds or even thousands of programmers, and are updated literally every day. Go is a programming language designed by Google to help solve Google's problems. And Google has big problems. Concurrency is an essential aspect of Go. I want to read verbatim the section of that talk on concurrency because it summarizes a lot of what I've been reading. Concurrency is important to the modern computing environment with its multi-core machines running web servers with multiple clients, which might be called the typical Google program. This kind of software is not especially well served by C++ or Java, which lacks sufficient concurrency support at the language level. Go embodies a variant of CSP with first-class channels. CSP was chosen partly due to familiarity. One of us had worked on predecessor languages that built on CSP's ideas, but also because CSP has the property, that it is easy to add to a procedural programming model without profound changes to that model. That is, given a C-like language, CSP can be added to the language in a mostly orthogonal way, providing extra expressive power without constraining the language's other uses. In short, the rest of the language can remain ordinary. The approach is thus the composition of independently executing functions of otherwise regular procedural code. Repeat. The approach is thus the composition of independently executing functions of otherwise regular procedural code. The resulting language allows us to couple concurrency with computation smoothly. Consider a web server that must verify security certificates for each incoming client call. In Go, it is easy to construct the software using CSP to manage the clients as independently executing procedures, but to have the full power of an efficient compiled language available for the expensive cryptographic calculations. In summary, CSP is practical for Go and for Google. When writing a web server, the canonical Go program, the model is a great fit. And there is one important caveat. Go is not purely memory safe in the presence of concurrency. Sharing is legal. Passing a pointer over a channel is idiomatic and efficient. Some concurrency and functional programming experts are disappointed that Go does not take a write-once approach to value semantics in the context of concurrent computation, that Go is not more like Erlang, for example. Again, the reason is largely about familiarity and suitability for the problem domain. Go's concurrent features work well in a context familiar to most programmers. Go enables simple, safe concurrent programming, but does not forbid bad programming. We compensate by convention, training programmers to think about message passing as a version of ownership control. The model is Don't communicate by sharing memory. Share memory by communicating. Our limited experience with programmers new to both Go and concurrent programming shows that this is a practical approach. Programmers enjoy the simplicity that support for concurrency brings to network software, and simplicity engenders robustness. This talk mentions garbage collection. Go has no explicit memory freeing operation. The only way allocated memory returns to the pool is through the garbage collector. CSP is communicating sequential processes. According to the wiki article, it is a formal language for describing patterns of interaction in concurrent systems. It is a member of the family of mathematical theories of concurrency known as process algebras. Excuse me. Can I say that again? It is a member of the family of mathematical theories of concurrency known as process algebras, based on message passing via channels. Don't communicate by sharing memory. Share memory by communicating refers to CSP. In order to implement concurrency, I assume that there is some fairly active low-level stuff going on to achieve this. There's some kind of hardware management going on, or perhaps more accurately, Go is managing resources as it is designed for the cloud. Concurrency is a major area I've barely progressed beyond knowing that you can just do a lot of stuff at the same time. My goal is not to learn how to program with Go. Go underlies PHP application servers, so my goal here is to grasp the essential concept of Go as it pertains to these PHP app servers. It sure seems to me that concurrency is the main proposition. Without concurrency, without Go's ability to do millions of things at the same time, without Go's so-called cheap and easy ability to achieve concurrency, well, Go's attraction as the language of choice for writing PHP app servers would diminish greatly. Now, as interesting as CSP is, as listening to videos about Go channels that are part and parcel of Go's concurrency, my gut tells me that right now, this granularity is for later, perhaps if at all. Something that I definitely remember about Go is that concurrency is cheap and easy. Concurrency is cheap and easy. Now, Go has something else. Server functions. In the Go standard library, there are web server packages under the net category. PHP has a server PHP has a server that is there as a convenience for development. The Go has a production-ready server, which I assume means that there's no need to install Nginx or Apache, which means that Go is the server, and Go is the high-level language, and Go does low-level stuff. And to an extent, just because I just would love to say this, maybe kind of Go extends even to the OS. To me, the language is not the server. There's an entire genre of software to fill the server role. However, the people involved with Go have deep experience in the holistic experience. When you view everything as one, when your mandate is open, when you are specifically setting out to solve problems, you're not going to confine your solution. We end up with a much-needed Swiss Army knife of cloud computing. That is how I'm conceptualizing it. When you have an intimate understanding of assembly, I wrote the C compiler and/or its direct predecessor, and was involved with creating Unix. And now you're looking at Google's vast cloud infrastructure, while we are benefiting from that holistic view. Now, my guess is that some of the things that are described in the PHP application servers are really things that Go does. My guess is that the words that the servers use to describe what Go is doing may not be the same words that Go uses, and my guess is that servers are implementing Go in specific ways to achieve things for PHP, so there's a value-added way of doing Go specifically to aid PHP. But digging into Go first, I could discern what Go is doing and what value-added stuff the app server is accomplishing by way of implementing Go. I'm quite sure that this journey into Go will prove pivotal in my getting through PHP application server's opaque terminology, and next month I am going to take a good look at Roadrunner. Thank you for listening to this 18th episode of my Bob Bloom Show, PHP Developer's Guide to PHP Servers and Serverless Part 2, Working Towards Go. My next podcast episode is scheduled for April 1st, 2024. You have been listening to a South LaSalle production. Opinions expressed are not necessarily those of South LaSalle, Bob Bloom, nor of the organizations represented. Links and materials discussed on air are available in the show notes for this show. Information contained herein have been obtained from sources believed to be reliable, but are not guaranteed. Podcasts are released under copyright. Rights are reserved. Email correspondence to the attention of Bob Bloom at bob.bloom@lasallesoftware.ca.